let us understand how to draw the pressure, volume and temperature entropy diagram for the air standard cycles. Air is used as a working medium. We will take the Stirling cycles. In this cycle, two processes are isothermal process, that is, the process is taking place at the constant temperature, and two processes are the constant volume process. First, we will take the process 1 to 2 in which heat rejected from working medium to the sink. So, heat is rejected to the sink and the working medium is used as air. So, this point 1 or this process 1 to 2 is taking place at the lower temperature. So, if we observe, here is the temperature, is the vertical line. So, this is the higher temperature point and this is the lower temperature point. So, we will select the point 1 is at the lower temperature. So, I will select here the point 1. Now, what is the effect when the heat is rejected to the sink? So, this is the isothermal process, that means temperature will remain constant. So, we have to show here the constant temperature. Now, during the heat rejection process, there is decrease in volume of the air. So, volume is getting decreased and the pressure is getting increased. So, these two are opposite to each other, pressure and volume. So, we have to show decrease in volume and increase in pressure. Now, when the heat is rejected to the surrounding, then there is decrease in entropy. So, we have to show entropy is getting decreased, that is S is getting decreased. Now, with the help of these signs, we will draw the diagram. So, process 1 to 2, here volume is getting decreased. So, this is the higher volume and here is the lower volume. So, we have to select the point 2, but pressure is getting increased. So, we will select the point 2 slightly above the point 1. So, here is the point 2. Now, we will connect this 1 to 2. So, here is the process 1 to 2. Now, we will move to the TS diagram. So, again temperature will remain constant but entropy decreases. So, we have to show the higher entropy, that is the point 1, then the entropy decreases. So, this is the lower entropy point and temperature will remain constant. So, we have to show the horizontal line for the constant temperature. We will show arrow also and we will show here T1 is equal to T2. Now, we will move to the process 2 to 3. So, this process is the constant volume. Now, during this process, compression of working medium. So, this is important. So, first we will write the volume will remain constant. Now, what is happening when the compression of working medium? So, when the air is getting compressed, its pressure is getting increased. So, we have to show increase in pressure. So, we know that pressure and volume are opposite to each other, but this time constant volume, that means volume will remain constant. So, it will affect on entropy, because as the pressure is increased, then its entropy will also getting increased. So, we have to show increase in entropy because of the constant volume. So, this time S is getting increased. Now, during the compression process, we know that internal heat is getting generated in the working medium. So, temperature is also getting increased. Now, we have to show this. So, volume remain constant and pressure increases. So, we have to show here straight vertical line because this volume will remain constant, and we have to show increase in the pressure. So, here is the point 3. So, this is the pressure P3 and we have to show V2 is equal to V3 because the volume is constant. Now, we will show on TS diagram. So, T is increased as well as S is also getting increased. So, how to show the point 3? So, T3 we have to show at higher temperature and we have to show S is greater than, that is S3 is greater than S2. So 2 is here. So we have to show on the right hand side, that is we have to select the point 3 is on the right hand side. So I will show here the point 3. Now we will connect this point and we will show arrow. Now we will move to the process 3 to 4, isothermal process. So heat is added from heat source to the working medium. So this is isothermal process, that means this temperature will remain constant during the process 3 to 4. So temperature will remain constant. So what is the effect when the heat is getting added? So when heat is getting added from surrounding to the working medium, then its entropy is getting increased. So we will show increase in entropy. Then what is the effect on volume as well as pressure? So here when the heat is added, then it is getting expanded. That means volume is getting increased and pressure is getting decreased. So working medium is getting expanded because it is the air or gas. So working medium is getting expanded. So when expansion is taking place, volume is increased and pressure we have to show in opposite direction, that is pressure is getting decreased. So we will show here. So volume increase, we have to show point 4 is on the right hand side and pressure is decreased. So we have to show in the downward direction. So I will show here the point 4. So here is the point 4, I will show arrow. Now temperature is remain constant and entropy increases. So we have to show the increase in entropy. That means point 3 entropy is here and we have to show increase in the entropy, that is on the right hand side, and temperature is constant. So we will show here the straight horizontal line. So here is the point 4. So here is T3 is equal to T4. Process 4 to 1 is the constant volume process, and during this process expansion of working medium is taking place. So during the expansion of working medium, its pressure is getting decreased. So we have to show the decrease in pressure. Then the volume will remain constant because this is the constant volume process. Then what is its effect on the entropy? So if we observe, when the pressure decreases, the volume must increase. But what is happening when the working medium expansion is taking place? So when the air is getting expanded, then its temperature decreases and some heat is getting rejected to the surrounding. That means this is the heat rejection process to the sink. So whenever the heat rejected, we know that there is decrease in the entropy. So we have to show decrease in entropy, that is S is getting decreased and temperature is also getting decreased. So we have to show decrease in temperature also because of this expansion process. Now we will show this. So volume remain constant, pressure decreases. So 4 to 1 we have to show the constant volume, that is straight vertical line, and pressure decreases. So we will show here V4 is equal to V1. Then the expansion of the working medium, that means the temperature decreases, entropy also decreases. So here point 1 we have to show with lower temperature and lower entropy than the point 4. So I will show here with curve and this is the arrow. So this is the PV and TS diagram for the Stirling cycle.